Welcome to Physics Prep. This is a question from TATA-GS 2019 and it has given us a circuit in which we need to find the final output C. So first off, we'll write this in terms of the variables. We'll check this one first. In that, what we have is A comes in and A, the whole thing needs to be complemented over because of the dot here, and the result of this goes to this one, which means this thing is dot, that is AND with B, and the whole thing is complemented over. Now again, the output here goes to this one, and then there's an AND. Now we go to the other part. First off, let's check this one out, in which we have B and B, and then we have to make a knot over here or complement it, and then the result goes out and mixes up with A. That is the same similar situation as the earlier case. So this is with A and there's a dot. Finally, the whole thing goes to the final gate, that is this one, and then we have to complement it over here. So this is what C is equals to. But now of course we have to simplify this one. So now let's begin simplifying this initial expression. Firstly, the rule that we need to remember, let me write a few rules here, that if we have got something like A dot B and then we complement this, we have to complement each element individually. It will be A bar plus, because the complement of dot is plus, and then we'll have B bar. So I'm going to start from the innermost element, A dot A whole bar. So A dot A whole bar, let's just look at that. A dot A and then whole bar. Now if A is 0 and the other is 0, then the final will be 0. And if A is 1, the other is 1, the final will be 1, and it will just be opposite. Which means this is just A bar. So the first one will be simply A bar dot B whole bar. Similarly, here B bar dot B whole bar. So again, using this rule, let me call it rule number 1. Using this, what I have here is A plus B bar dot B plus A bar. And now I can use the distributive property that is all very common in normal algebra. A dot B plus B bar dot B A dot A bar plus B bar dot A bar. Oh, and I forgot that there was a complement here over each of these elements. So this gives us A dot B remains as it is, but I think we can simplify B bar dot B. So let's consider B bar dot B using a truth table. So this is B bar, this is B, and this is the result B bar dot B. Now if B is 0, B bar is 1, and if B is 1, B bar is 0. The only possible solutions are 0 and 0, which means B bar dot B bar is simply 0. The third term, A dot A bar, must also be 0, and B bar dot A bar is left to us. We can simplify this further by first grouping the terms, and then we get A dot B whole bar plus becomes dot if we use the complement, and this is one part. The other part is B bar dot A bar and whole complement. So this gives us A bar plus B bar dot B plus A. We simplify this further using the distributive property first. A bar dot B plus A bar dot A plus B bar dot B plus B bar dot A. this gives us a bar dot b plus b bar dot a. The middle two term vanish by the logic we mentioned earlier. So this is something we can make a truth table for. We will have a bar, b bar, a bar dot b bar dot a, and we need one more column for the final result. So this one here will be the final result, that is a bar dot b plus b bar dot a. So the values we can assign to a and b is 0, 0, 0, 1, 1, 0, 1, 1. So a bar becomes 1, 1, 0, 0. B bar becomes 1, 0, 1, 0. A bar dot b becomes a 0 here since b is 0. Here both are 1. Here b is 0. Here a bar is 0. Here a is 0. Here b bar is 0. Here both are 1. And here b bar is 0. So our final result, which should be the OR of these two, there's a plus here. So 0 plus 0, 0, 1 plus 0, 1, 0 plus 1, 1, 0 plus 0, 0. Now what we need to observe are the cases when this is 1. This is 1 when I have got b as 1 and a as 0, and again when b is 0 and a is 1. What's happening here is that the result is true if and only if only one of the inputs is true. That is, either A is true or B is true but not both. This is a characteristic of the XOR gate or the exclusive OR gate, and that is our answer.